that's a circle with a diameter of 80 millimeters. These are tangents here, yep. Bottom one is also tangent. These angles are the same. Those two angles are the same. In other words, this thing's symmetrical. That's 150 millimeters. I want you to find this angle here, angle theta, and the area. I'm going to give you a couple minutes, see if you can see what you can come up with on your own. I don't necessarily expect you to accomplish the whole thing, but see what you can come up with, see what you can chip away at. Just because I want you to get used to starting to break these problems down, even if you don't get it done, just to see if you're heading in the right direction. So I'll give you, let's see if you're heading in the right direction. Where should you start here? Like that? What do, 75. Oh, you mean 75 and 75 like that? Okay, that makes sense. What else do we know about this line here, this blue line? It's 40 millimeters, yes, and it is a right angle. What else should we draw in? Should always draw in the right angles for the radii of the tangents, wherever we can, see what that does for us. How many of you made it that far? No? Okay, I'm gonna give you a minute from there then. Next step in the process. Looks like that. I'm only gonna draw it on the one side, but you know you can do it on both sides, right? We would have, let's draw it in over here too. We would have now 4 identical triangles. I'm gonna draw one of them. I know this is 40 and this is 75. I can now find that angle. How would I find that angle? Inverse tangent, yes. Tangent of an angle is equal to opposite over adjacent. We're looking for the angle here. Opposite's 40, adjacent 75, so it's going to be an inverse tangent to find that angle. So second tangent, 40 divided by 75. Ah, shoot, I gotta change my modes again. Nope, I'm in degree. 28.07 is correct. So that means this angle is 56.14, correct? Just two of those together. What's this angle up here have to be? Nine, 180 minus 90 minus 28, that's 180 for the whole triangle, right? So that makes this angle here 123.86 degrees. Makes this angle here 123.86 degrees. Makes this angle right here 112.28 degrees. We now have everything we need to find the area of that. And the area is actually going to be a lot simpler than you would think. We've got 1, 2, 3, and 4 here that are all the same. They're 40 by 75 triangles. So 40 by 75 divided by 2. How many of them are there? 4 of them. So times 4. What is that? 6,000? Millimeters squared. Object 5 up here. is going to be found by doing a circle. That'll be pi times 40 squared times the 112.28 over 360. $1566.93. So we add that up. 7,566.93 square millimeters. Was there anybody within like 10 millimeters squared of that? So this got you got exactly? Cool. How many of you were on your way there if I'd given you more time? How many really want to bury your head and cry? Okay, we're gonna try another one of these. Let's say our diameter is 50 millimeters. We're gonna call this 120 millimeters. Go ahead and find the angle. Those are both the same, and the area. So we draw in our radii. We get this little triangle, 25 by 60. That angle there is the inverse tangent to 25 over 60. 22.63. We'll settle the argument here. 22.62, yes. 22.62 degrees. So this is 45.2324, somewhere in there. Which makes this angle right here, well, I've already doubled it. 134.77 after you double it. But yeah, 67.38385, somewhere in there. So this is the same that makes this one up here 108. That's a little big. What do I have there? 269.54. I got 90.46. Does that sound right? Close. Good enough for who it's for. It's just 360 minus this and minus the same thing again. So we have those triangles that are 25 by 60 divided by 2 and then times 4, which is what, 3,000 total? And then we have a circle. It'll be pi times 25 squared times 90.46 over 360. $493.13. Adds up to give us a total area of 3,493.13. If you're within, like I said, 3 or 4 millimeters squared of that, you're doing great. Any questions? Down here? What'd you, when you did the inverse tangent here, what'd you get? So that should give you this angle here. You double that to get this one. So the 45.23 has to be it. Because that angle there is this half angle here. So you double it to get the full thing. What are you doing to get 60? An inverse tangent or inverse trig or something? This one here? Or this one? Oh, you're like this? Okay, the problem with that one is we only have the one side. Because this angle here would still have to be 22.62, but we don't have a way of finding it because we only have this side. We don't have this tangent length here. And we could figure out that it's going to be 60. That's a very good question. Why isn't that? Oh, and if you do it that way, it will keep telling you this is 30. Yeah, you would have to know that this goes straight through, and it doesn't necessarily. It looks like it goes straight here, but in reality, it does take that hook off to the side like that. Yeah, you can't use that triangle. That's why that doesn't work. It was a good idea, though. I mean, you had me stumped for a second. Hey, you gotta try, right? Okay, so here's what we have here. This is 120 millimeters across here. From here to here is 30 millimeters. That's the straight up. This circular portion here has a radius of, oh, let's go just for fun, 20 millimeters. I want to know what's the length of this straight piece across here. We'll give you guys some time to think about that one. So if we cut that in half, that's 45, this is 45, that's 90, it adds up to 180. This is going to be 60 millimeters. How do I know that? Yeah, this is 60 down here, half of the 120. 45 degrees, I could do a tangent if I wanted to, but since it's 45 degrees, I know that it's just the two legs have to be the same because the angles are the same. So this is 45 degrees here. That makes this 45 degrees. And there is a right triangle formed up here somewhere, making this 45 degrees. That's a right angle because those are verticals and horizontals, right? And I know that's 30 millimeters on that side, but I noticed the center is not somewhere along that line. It's not at the end of that line. I'm gonna let you mill it over from there. I'm gonna throw a worksheet at you for homework here quick. No, let's have a good